You don't have to determine if you're using cosine, tangent, or sine. You are always using sine, hence law of sines. Okay? So don't switch it up. So you have used right triangle trigonometry to find the height of trees and other items that are perpendicular to the ground. So before we had perpendicular, so we made a 90-degree angle with our triangle. What if an item is not perpendicular to the ground, like a tree that leans due to weather damage? To calculate the length of such trees, you must use other forms of trigonometry. Okay, so today we're not looking at right triangles. Okay, not looking at right triangles, so you can't use SOHCAHTOA. However, we can use law of sines and law of cosines to find different side lengths and angle measures. So these two laws can be used with any triangle. Okay, so before we only had right triangles, you had to have a right angle within your triangle. Now you can have acute triangles and you can have obtuse triangles in order to use this. So our law of sines are just ratios. Okay, so I have sine of A. Again, your angle is always attached. Okay, so that capital letter in each of these is an angle. So sine of A over lowercase a is equal to sine of B over lowercase b, and is equal to sine of C over lowercase c. Now these lowercase letters are the opposite sides to those angles. So if I look at angle A, okay, and I'm taking sine of A, I need to put it over its opposite side. That's where they're getting that lowercase a from. Okay, that's equal to sine of B. So again, your angle B right here, and it has to go over its opposite side where they're getting lowercase b. Okay, so sine of an angle over its opposite side. Sine of an angle over its opposite side. Okay, that's all law of sines is. So to use law of sines, you have to have the measures of two angles and any side. Okay, so you have to have the measure of two angles and at least one side. Now when we use law of sines, you don't need to use all three angles. Okay, so you can look at it as just this ratio equal to another ratio. Okay, you don't need the third one to set up an equation. So we are going to practice this. In example 1, we want to solve for x. So what I do is locate my two angles that I'm given. Okay, so I have angle A and angle C. I make sure that there's a side opposite those angles. So if I look at angle A, that's 97 degrees. Okay, I make sure there's a side with a variable or a number across from it. Okay, same thing with 21 degrees here. If I want to use that angle, I have to make sure there's a side opposite that angle or across from. Okay, and that's my variable, so I for sure need to use that one. So from here, now that I've located my angles and their opposite sides, I can just plug this into the law of sines. Okay, so I would take, make sure you can see this, sine of an angle. Okay, so I'll do sine of 97. Okay, so that A is always an angle. Okay, that has to go over its opposite side. So 97 degrees is opposite 16. Okay, that's equal to sine of your other angles. So this time I'm going to use 21 over its opposite side is x. Okay, and that's all I need to do. I don't need to do the third one. You just need two. Okay, you only need two. Now, whenever you have two fractions, okay, equal to each other, we can cross multiply to solve. Okay, so I can cross multiply here. So 16 times the sine of 21 and x times the sine of 97. Okay, that's only if there's an equal sign between the two. Okay, if those were multiplied together, you cannot cross multiply. So here I would take 16 times the sine of 21. And yes, I would write 16 in the front, okay, not behind. In your calculator, you don't want to multiply 21 and 16 together. Okay, so after I multiply that, I have equal to. Then I'm multiplying my other two, so x times the sine of 97. Now I'm trying to solve for x, so I want x by itself. So since these are multiplied together, I would divide both sides by sine of 97. Okay, so that it cancels out over here. Okay, then I have x is equal to 16 times the sine of 21 over the sine of 97. And this is what you need to plug into your calculator. You have one. If you need to see that, you do need to be careful when you do this. So this is where you do need to end your parenthesis. Okay, so I would type in 16 sine of 21, end your parenthesis before you divide. Okay, so end that parenthesis, then divide by the sine of 97. Okay, to get about 5.8. So you do need to end that parenthesis first. You get what? All right, questions on example 1? Questions on example 1? All right, then we're going to look at example 2. Okay, so again, I have these two angles here. I want to make sure there's a side opposite those angles. Well, if I look at 31 degrees, okay, x is across from that, so it does have that opposite side. However, if I look at angle W, this 63 degrees, and I go across, there's no number and there's no variable there. Okay, so I don't want to use that angle in law of sines. Okay, however, I do have this side of 14, okay, and that's across from that angle T, right? Well, if I have two angles of a triangle, how can I find the third one? Subtract from 180. Good. Okay, so I would subtract the two angles that I know from 180 to get that remaining angle so that I can use it in law of sines. Okay, that is 86. So that's the angle I want to use. Okay, it is 86. That's the angle I want to use because I have a side opposite that angle. Okay, from here, again, all I do is use the law of sines. So I would take sine of my first angle, so sine of 31, over its opposite side. This one is x. That'll be equal to sine of my second angle I want to use, so 86, over its opposite side is 14. Now don't try and find that missing side. Okay, so I have students each year who think, oh, I'll just use the Pythagorean theorem or I'll find that missing side somehow. Don't do that. Okay, find your other missing angle and use that angle. Okay, you can't use the Pythagorean theorem. One, you already have a variable for this side. You can't just guess what it is. You can't use special right triangles. Okay, this isn't 30 and this isn't 60. Okay, it's 31 and 63. Okay, you cannot use special right triangles to guess what that side is. So find that missing angle instead. Now from here, after I set up law of sines, again, all I do is cross multiply. So multiply across that equal sign right here. So I have 14 times the sine of 31. Okay, then that's equal to, again, cross multiply. We have x times the sine of 86. And again, I want x by itself. So we need to divide out the sine of 86 from both sides so that it cancels on the right. Okay, so try and enter that into your calculator again, just so you know you can do it correctly. Okay, enter that into your calculator. I'm going to give you a little time so you can enter it into your calculator. So I want you to practice that. I got 7.2. 7.2. Okay, questions on your first two problems here? All right, do example 3 and example 4 on the back. Similar to the first two we just did. Example 3 and example 4 on the back. If you get through 3 and 4 and want to go for 5 and 6, you can do those ones too. All right, so if you're still working on 4, that's fine. I'm just gonna go over 3 really quick here. So example 3, you were given both of your angles here and they do have opposite sides. So just using the law of sines then, from here I can cross multiply. So I have 28 sine of 35 is equal to x times the sine of 48. You do need x by itself, so you do need to divide out sine of 48. So we have 28 sine of 35 divided by sine of 48. Okay, and you should have gotten x is equal to 21.6. Okay, so x is 21.6. How do we feel about that one? Good. Okay, terrible. Good? Okay. Then number 4 was like number 2. Yeah, if you guys are done. So this one, I have this angle of 52. I do have an opposite side of x. However, your angle for 91 degrees does not have an opposite side, right? But I do have this side of 20. Now that side of 20 is opposite this other angle. Okay, meaning I need to find what this angle is here. And again, to do that, use your subtract from 180. And I got that angle to be 37. Okay, from here I can use the law of sines. So I have sine of 52 over x equal to sine of 37 over 20. Now you can flip-flop those two fractions. Okay, that doesn't matter the order. All that matters is whatever angle you use, it should be over its opposite side. Okay, so if your fractions are flipped around, that's okay. From here, cross multiply. Okay, and then divide out that sine of 37 to get x by itself. Okay, so you get x is equal to 26.2. How do we feel about that one? Good? We did okay? Yeah? For those of you who did 5 and 6, okay, those of you who did 5 and 6, if you haven't done 5 and 6 and would like the extra practice with this before you take your assignment, your answer for 5 was 12.2. And your answer for 6 was 30.4. Since a lot of you came up and took your assignment already. So I'm guessing you finished that note sheet. Okay, so your answers there would be 12.2 and 30.4. Okay, it's the same process as 1, 2, 3, and 4. Okay, same process each time. Anybody do 5 and 6 that had questions or did not get that answered?